myself Abhishek Reddy. Today I am going to teach investigation of the structure of biopolymers. My subtopic is the method of nuclear physics. In modern nuclear physics, which makes a use of powerful beams of chemistry, particles like electrons, neutrons, etc., offer also such methods as X-ray diffractions using Skinner radiations and neutron diffractions for crystalline and dissolved biopolymers. Synchrone radiations offers important possibilities for X-rays, spectroscopy, X-rays, quanta, and energy just enough for the inner electrons in the form to be ionized the X-ray absorption and shows the fine structure of the absorption band. This structure is the result of the reflection of the spherical wave emitted by the primarily observed. This use of the his method EXAFS, and here we are in condition H is equal to HMV. H means Planck constant, and V is velocity, M is mass of the particles. A beam of neutrons from an atomic reactor is subjected to monochromatisms by reflections from a crystalline plates. And X-ray diffractions. X-ray diffractions nutation, it has been shown that each hydrogen atoms which form covalent hydrogen bond. Okay, and next is O, and O is single bond to the H, and it reacts to oxygen. May occupy two positions. The one is shown above, and the second one is OHO. Here, in other words, the proton may reach its own oxygen atom, and near a process oxygen atom, the hydrogen bond in water is characterized by the jumps of protons between two equivalent minimums neutron. Diffraction has been successfully employed by investigations of biophysics, scattering of X-rays by changing the fraction of heavy in an aqueous solution of a biological objects. And one can carry the overall amplitude of neutrons. Scattering this reveals the selective scattering of different functional group of has been possible. And next I want to example to investigate the nature of the complex for motion of proteins and DNA chromatids. And next, a specific methods of structural studies of biopolymers is Y resonance spectroscopy. Based on this mass based effect, this effect consists of the resonance absorption by an atomic nucleus of the monochemical Y radiation emitted by a radioactive atoms. All natural compounds of iron contains 2.2% of the isotopes and 37 IFE. This makes it possible to study iron containing proteins like hemoglobin, myoglobin, and cytochromic, etc. Apart from the hemo containing biopolymers for structures determination, one can be emitting isotopes as labeled atoms, and the mass Bohr effect on the analysis. Next, apart from absorption, radiation spectra, emission spectra are also studied. The source contains atomic structures that are present or parent nuclei with respect to mass basis nuclei. The emissions method has been used for studying the structure of a number of true physics of cobalt. Cobalt is it is a element, and vitamin B12 and others are the sensitivity of the emissions method is very high, and biological process. The process of the application of Y resonance spectroscopy are associated first with the development of mass brain I and etc. And so thanks.